Arrowheads is not a specific number. It's infinities, right? And it had it on both ends, so it was all reals, because it just keeps going forever and ever and ever and ever and ever. Now, granted, it looks like it's gonna. You guys don't know about asymptotes yet, so we're just gonna assume it just goes on forever because they haven't given us an asymptote. So here then you have arrowheads that it's shooting off here and it's going and it's going and it's going. So eventually this is going to be a slower coverage because it's slowly doing it. Here it's shooting off very quickly. So you have both axes activated. Same here, it's going to keep falling. It does move over to the right, but again, the right movement is definitely slower than the vertical downward coverage. So again, both axes are being used, right? They're being represented in the graph. You can put in any number and you're going to get a value out, okay? So if you're looking at domain and range, what do you think my domain is for this cubic function? If it has arrowheads, what is it? Yeah, infinities. So this is just going to be all reals. What's my range? Same. It has arrowheads. So all reals, it goes forever and ever. And that, right, I don't want to color code it the pink and the green, but it's going to move forever. Okay. The Y is covered faster. The Y values are covering faster than the X values. You could also plug in any number into the equation. So if you have negative 0.25, say I put in 1,000, okay, that's 10,000, plus 3 cubic minus 1, I can put in a 10,000 value X and I get just some huge Y value. So I didn't get error, I got a number, which is telling me so far my independent variable X doesn't have a restriction on it, okay? I could plug in negative 1,000. Where's my negative? Negative. And I get a value. I didn't get error. I didn't get rejected. So both values, the positive and the X axes, there's no restrictions, right? You can go more, but okay. All right. Okay, end behavior, we'll get to that, but now your function notation. When f is -1, what did you get? It was in our table. What is it? You can substitute it and solve it, but we kind of found it in our table. F of -1 is what output? -3. Do you guys understand that, right? You could go ahead and substitute, but I kind of knew, I looked ahead of time to see what these numbers were, so then I kind of put them in the table. It's 2 birds with 1 stone. Okay, f of -7, I went down to -6. I didn't find -7, so I'll have to put in the -7. But you know, -7, it's going to be really high up, like maybe in the 20s or something. So if I substitute -7, and just, okay, what is the big error with cubic functions? It's a cubic function, so this is a cube. A lot of you on tests, individual tests and quizzes, you're gonna hit the square. So when you're doing quadratics, most of you are programmed, because all last year you did an entire semester of quadratics, you cover that material. Your finger wants to go to the square button, and you do everything beautifully, but your numbers are off, your graph is off. Just make sure if it's 3, 4, 5, make sure like you consciously stop what you're doing and say it's a cube, and you hit the cubic button, okay? It happens every quiz, every test, you guys. Like, I haven't had a class that hasn't done that. Okay, I hit equal, and I get 15. Are you guys okay with that? Okay. All right, so now you have to find the Y values. I'm sorry, you have to find the X values given the Y values. So they give you the output, what's the input? And so you have to solve. Let me write bigger. So this is Y equal -0.25. cubed minus 1. Okay, they want to know, this is the input, this is the output, right? This is x, this is y. So y is negative 2. X plus 3 cubed minus 1. You have to isolate x, which means it's just like when you're solving for kind of the inverse function. You got to get x by itself. So it's the same steps. I don't know if I have it though. Oh, yeah. Okay, so if I just kind of put this over it. Remember, we were solving for the inverse, or we were looking for the critical points, right? And we were doing x-intercept, y-intercept, vertex. This is always it. K, A, inverse the function, H. Non-negotiable, this is it. K, A, inverse the function, H. That's it. So when you come to this, when you come to this, I want K. What's my K? What number is the K? Negative 1. So what is it going to become on the other side? Positive 1, right? So I get negative 1. Okay, A. What's my A? So what do I do with that? What's the operation? Add, subtract, multiply, reciprocal, divide. What? Huh? Remember, it's right next to a parenthesis, so it's not a separate term. You have reciprocal multiply or divide? What's easier for you guys? This is what I mean, like if I'm confusing you. Like say you have 5 equal to x. Granted it's 0.25, but what do you guys do, like that? Yeah? Does that look familiar? Okay, so what do you call that? Divide it out? Yeah. Okay, but remember, you're also reciprocaling it, right? Had it been a 1/2, you would have gone 2 over 1, right? Okay, bless you. Right, so what I mean is, remember, if you ever want to know what you have to do, go back to the basics. What do you know? I know if I want to find that, I'm going to go 3 over 1, 3 over 1, right? And then that comes out, that's x, this is 15. Here, I get 5/2 is x. So whatever your language is that you prefer. Okay, so here, that negative 0.25, I need to move it to the right. So do you say divide, right? But you're essentially reciprocaling, right? Because it's not a separate term. There's no add, subtract. So now divide by negative 0.25, divide by negative 0.25, and so I get, and now that's, I would put it in the calculator. Oh wait, I forgot my y. Oh wait, no, we put in the y, duh. You guys, I thought we were inversing right now for a quick sec. I was like, oh my god, I just messed you guys up. It's because that's what we're gonna do next, so that was in my head. I was like, oh my god, fail. Okay, right? Clean it up. Is that okay? Okay, so I get 4. And that should make sense because, right, this is negative 1. This is negative 1/4, right? A quarter is 4 quarters make $1, right? So 0.25 is 25 cents. What's the reciprocal of 1/4? 4 over 1. Take it to the top, 4 over 1. What's negative? So this goes out. What's negative, negative? Positive. What's 1 times 4? 4, right? Okay. All right, what's my next? Ka. Inverse the function. The function is a cubic function, so you're going to cube root it, right? Whatever that degree is, that's the degree of your root, right? Okay, so it's, oh, let me use the red again, sorry. So cube root, so we'll put this in the calculator. And then this just comes out as x plus 3. The radicand just comes out, right? Okay, so you get your calculator. What's a cube root of 4? Again, stop what you're doing if you're talking to your friend. Make sure you hit the cubed root. It's this little yellow. There's that yellow right there. See it? Okay, so I hit shift, that button. See it? There's the 3. And then 4, hit equal. It's not plus or minus though, you guys. It is just positive 1.9. I mean, I'm sorry, 1.6. Is that okay? Yeah, okay. So then, but remember, if you guys are going to go to Desmos and you want to verify your graph to Desmos, you probably want to go 0.59. The more places, like significant figures you grab, it'll match Desmos better. If you guys are clipping to the 10th, just know, like, I think that one graph we did, I was off by like 2 or 3 tenths. So as long as that doesn't throw you off, okay? All right, so 1.6 is equal to x plus 3, right? Okay, so now take that, and now it's h. So Ka inverse the function, sorry, h, take that -3 to the front. So I get -3 plus 1.6 is equal to x, and what is that number? -1.4. And that is the answer. Oh yeah, to this one. I'm doing something on my phone otherwise. And then if we looked at the graph, right? If you look at your graph, when y is -2, what is the x value? So when you're at -2, this is -2. If you find it, this is kind of the point. So this is saying it's about -1.4. This is -1, this is -2. This is about the half. So our graph, whoops, you can't see. Our graph supports this -1.4. How are you? Oh, okay. Here, I'm almost done. I'm gonna stop it right here. Okay, so the graph supports it. All right, so I'll leave it here, and then I'll stop the video. Because the video's, it's on 12 minutes already, you guys. Okay, Lenai. Stop it. Yeah, take a picture of it, because it's on 12 minutes.